Other notations. If we use the traditional notation to indicate that the independent variable is x and the dependent variable is y, then some common alternative notations for the derivative are as follows. F prime of x is also equal to y prime, which can equal dy over dx. That's a derivative with y with respect to x, which is equal to df over dx, which is also equal to d over dx times f of x, which is equal to df of x, which is equal to d with respect to x, f of x. Now, the symbols d and d over dx are called differentiation operators because they indicate the operation of differentiation, which is the process of calculating a derivative. Now, the symbol dy over dx, which was introduced by Leibniz, should not be regarded as a ratio for the time being. It is simply a synonym for the derivative, f prime of x. Nonetheless, it is very useful in suggestive notation, especially when used in conjunction with increment notation. Now, referring to equation 2.6.6, we can rewrite the definition of derivative in Leibniz notation in the form dy over dx, which is equal to the limit as the change in x approaches 0 of the change in y over the change in x. Now, if we want to indicate the value of a derivative dy divided by dx in Leibniz notation at a specific number a, we use the notation dy over dx as x is equal to a, or dy over dx with that notation as x is equal to a, which is a synonym for f prime of a. Now, which leads to our definition number 3. A function f is differentiable at a if f prime of a exists. It is differentiable on an open interval ab, or a to infinity, or negative infinity to a, or negative infinity to infinity, if it is differentiable at every number in the interval.